Now derive the equation of a plane perpendicular to a given vector and passing through a given point both in vector and Cartesian form. What is the condition for perpendicularity? A dot B is equal to 0. That means vector AP dot N is equal to 0. Let us draw a circle. This is a circle with O center and A is the radius. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed the 5 marker questions from part D for this model question paper 21-22. Now I will discuss the remaining problems in part D for 5 markers. Now let us come to the first problem. What is the first problem? Now all the problems are from volume 2, that is integrations, application of integrations, differential equations, then 3D geometry and probability. Okay, now let us come to the problem integration. Now find the integral of 1 over x square plus a square with respect to x, and hence evaluate integral 3x square divided by x to the power of 6 plus 1 dx. Now let us come to the solution. What is given? Given integral is integral 1 over x square plus a square dx, or a square plus x square is same. Let us take the substitution. Put x is equal to a tan theta. Now differentiate this. Differentiating with respect to theta, dx by d theta is equal to a into differentiation of tan theta is secant square theta. Dx is equal to a secant square theta into d theta. Now let us take the substitution. Put x is equal to a tan theta, dx by d theta is equal to a secant square theta, dx is equal to a secant square theta d theta. Now this given integral reduces to integral 1 over, what is x? A tan theta whole square can be written as a square tan square theta plus this a square as it is, and what is dx? Dx is equal to a secant square theta into d theta. Now this is integral 1 over, you can take a square out, then what you will get? Tan square theta plus 1 into a secant square theta d theta. 1a and a gets cancelled, 1 over a into secant square theta d theta divided by 1 plus tan square is again secant square theta. So this is secant square theta gets cancelled. What you will have? 1 over a into integration of d theta. This is 1 over a into integral of d theta is theta plus c. Now this is 1 over a into, now from this x is equal to a tan theta, x by a is equal to tan theta, or theta is equal to tan inverse of x by a. So this is equal to 1 over a tan inverse x by a plus c. This is the integrated answer. That's it. Okay. Now, so therefore, I can write integral 1 over x square plus a square dx, or this can also be written as 1 over a square plus x square dx. One and the same. The answer is 1 over a tan inverse of x by a plus c. This is the required answer. That's it. Okay. Now see here, put x is equal to a tan theta, differentiate it. Dx by d theta is a secant square theta. Dx is equal to a secant square theta d theta. 1 over a square tan square plus a square, you can take a square common factor, tan square theta plus 1, a gets cancelled, 1 plus tan square is secant square gets cancelled, 1 over into integration of d theta is theta. What is theta? Tan inverse x by a. Substitute here. Therefore integral of 1 over x square plus a square dx is 1 over a tan inverse x by a. Now next, second part. What is part 2? To evaluate 3x square divided by x to the power of 6 plus 1 into dx. Now let us convert this as, this is 3x square dx divided by x cube whole square plus 1 square. Now let us take the substitution. Put t is equal to x cube, differentiate it. Dt is equal to differentiation of x cube is 3x square dx. See, this 3x square dx becomes dt divided by x cube is nothing but t square plus 1 square. Now this is of the form 1 over a square plus x square. This is 1 over a, 1 over t tan inverse of t by 1 plus c, that is 1 over 1 is 1 into tan inverse of t plus c. What is this equal to? Tan inverse. What is t? What is the substitution you have taken? T is equal to x cube. 1 over 1 is 1. Then this is tan inverse of x cube plus c is the integrated answer. So the required answer is tan inverse of x cube plus c is the required answer. Hope you followed. So if you do this much, definitely you will get 5 marks. Okay, 4 marks for that, 1 marks for this solving the problem. Now let us come to the next problem, 59. What is 59? Find the area enclosed by the circle x square plus y square is equal to a square by integration. Now x square plus y square is equal to a square using integration. Now this is the standard question. You know the area of a circle as well as the equation of a circle. So the area of a circle is pi r square. Instead of r, it is a square. The answer for this problem is pi into a square. That is what you are going to get. Now this can be evaluated. Now what is given? Let us consider a circle with O center and a is the radius. The equation of a circle is x square plus y square is equal to a square. Now the area enclosed by the circle, the area of a curve is given by area on x axis is given by integral a to b y dx. Okay. Now the area of this, let us consider this O, A and B. Area of sector OAB, the entire area, the area of circle is equal to 4 times area of sector OAB. So that is equal to 4 times integral. What are the values here? Here x is equal to 0 and x is equal to a are the ordinate. This is 0 to a y dx. Now this is equal to 4 times integral 0 to a. What is the curve given? X square plus y square is equal to a square. From this, x square plus y square is equal to a square. Y square can be written as a square minus x square, or y is equal to root of a square minus x square. So this is 4 times root of a square minus x square into dx. That's it. So if you evaluate this, you will get the answer. That's it. So you know the standard result. We know the value of integral root of a square minus x square dx. The standard result for this is x by 2 into root of a square minus x square plus a square by 2 sine inverse of x by a. This is the result. So root of a square minus x square is equal to x by 2 into root of a square minus x square plus a square by 2 sine inverse x by a. Now therefore the required area, area is equal to integral 0 to a 4 times root of a square minus x square dx. This is equal to 4 times. What is the standard answer for this? X by 2 root of a square minus x square plus a square by 2 sine inverse of x by a between the limits 0 to a. Just apply the upper limit. So this is 4 into upper limit is a by 2 into root of a square minus a square plus a square by 2 into sine inverse of a by a minus lower limit 0, x into 0 is 0 plus a square by 2 into sine inverse of 0 by a is 0. Now simplify this. This is equal to 4 into, this is 0, a square minus a square is 0, 0 into any number is 0 plus a square by 2 into sine inverse of a by a is 1 minus sine 0, 0, this entirely becomes 0. Now this is 4 into a square by 2 into what is sine inverse of 1? Pi by 2. So this 2 2s of 4 gets cancelled. This is equal to pi into a square. So therefore the required area, area is equal to required area is equal to pi a square units. This is the required, very important problem. So the area of a circle x square plus y square is equal to a square is pi into a square. That's it, very simple. Okay. Now I will explain once again. The area of a circle is given by integral 0 to a y dx. So, this is nothing but, let us find out the area of one sector and multiply by 4. So, therefore, the required area is equal to 4 times integral 0 to a y dx. What is y? Y is equal to root of a square minus x square. Since we know the standard result for root of a square minus x square dx is x by 2 into root of a square minus x square plus a square by 2 sine inverse of x by a. Just apply the upper limit and lower limit. So, this gets cancelled 0. Sine inverse of 1 is pi by 2, a square by 2, pi by 2, a square by 2 into sine inverse of 1 is pi by 2, remaining things gets cancelled, 2 to the 4 gets cancelled, that is equal to pi into a square is the area of the circle. That is it. Hope you followed. Now, let us come to the next problem. The next problem is from differential equation. This is also an important. Solve the differential equation. Find the general solution of the differential equation. X into dy by dx plus 2y is equal to x square, where x is not equal to 0. Now, what is the problem given? The given equation is x into dy by dx plus 2y is equal to x square. Now, let us divide by x first. Divide by x. So, then dy by dx plus 2 by x into y is equal to x square by x is 1. Now, compare this. Comparing with the standard linear differential equation, dy by dx plus p into y is equal to q, a linear differential equation of order 1. So, here what is p? P is nothing but the coefficient of y, p is 2 by x, and q is nothing but x. Now, p is equal to 2 by x and q is equal to x. Now, if you divide by x, you will get dy by dx plus 2 by x into y is equal to x square by x is x. Now, comparing with the standard equation of a linear differential equation, dy by dx plus py is equal to q. What is p? P is nothing but the coefficient of x, 2 by x. What is q? Q is this x value. Okay. Now, here p is equal to 2 by x and q is equal to x. Now, find out the integrating factor first. The integrating factor is given by if is the integrating factor is e to the power of integral p dx. So, this is e to the power of p. What is p? 2 by x. 2 by x dx. So, you can write e to the power of 2 out, 1 over x dx. 2 into integration of 1 over x is log x. So, this can also be written as n log m is log m to the power of n, e to the power of log x square, en log x cancel, this is equal to x square. So, therefore, the integrating factor is x square, the first part. So, after converting into linear differential equation, find out the integrating factor. Integrating factor is e to the power of p dx, p is 2 by x, take to constant, integration of 1 over x is log x, this is n log m is log m to the power of n, log x square, en log x cancel, that is equal to 1. So, x square into 1 is x. So, integrating factor is x square. Now, let us come to the solution. The solution is given by, what is the formula for solution? Integrating factor into y is equal to integral of integrating factor into q dx plus c. That is it. Integrating factor into y is equal to integral of integrating factor into q dx plus c. What is integrating factor? X square. X square into y is equal to integrating factor x square into q. What is q? Q here it is x. Q is equal to x. X into dx plus c. So, x square into y is equal to integral of x square into x is x cube dx plus c. That is x square into y is equal to integration of x cube is x to the power of 4 by 4 plus c. So, if you want, you can stop here itself or divided by x square. If you divide by x square, what you will get? Y is equal to x square divided by 4 plus c by x square. This can be written as, therefore, y is equal to x square by 4 plus c into x to the power of minus 2 is the required answer. That is it. This is the solution for the given differential equation. That is it. See here, after finding the integrating factor, take the formula. What is the formula? The solution is given by integrating factor into y is equal to integrating factor into q dx plus c. What is the integrating factor? X square into x dx plus c, or x square y is equal to x into x square is x cube, integral of x cube is x to the power of 4 by 4 plus c. Now, just divide by x square, then x square gets cancelled, y is equal to x square by 4 plus c by x square. If you want, you can transfer x square to the numerator, then this is x square by 4 plus c into x to the power of minus 2 is the integrated answer. That's it. Very simple, very important. Instead of doing matrix and determinants, taking risk, if you go through these type of problems, then it is very easy for you to get the full marks for the problems. Okay. Now let us come to the next problem. Now the next question is from 3D geometry. So analytical geometry of 3-dimensional analytical geometry. Now what is the problem? Derive the equation of a plane perpendicular to a given vector. So here the derivation of a plane is given. So there are 3-4 derivation in which equation of a line, first 2 derivations for equation of a line and equation of a plane 2 derivations. In these 4 you will get 1 definitely for the point of examination. Here what is the question given? This is the equation of a plane. Now derive the equation of a plane perpendicular to a given vector and passing through a given point both in vector and Cartesian form. So here the equation of a plane is to be determined. The equation of a plane perpendicular to a given vector and passing through a given point in both Cartesian and vector form. Now let us consider a plane. Let a plane is passes through a point. Let us consider a plane passes through a point A whose position vector is vector OA is equal to A. Let us consider a plane which passes through a point A whose position vector is vector OA is equal to vector A. Okay, and this is perpendicular to the vector n, and this plane is perpendicular to the vector n and perpendicular to the vector n. So let this R is the position vector of P. Let P is any point, then the position vector of any point P x, y, z is vector OP is equal to vector R. R is the position vector of the point. That means let us consider, let a plane passes through a point A whose position vector is vector OA is equal to A. Let this plane is perpendicular to, this is perpendicular to the vector n, perpendicular to the vector n. Let P x, y, z be any point on the plane whose position vector is vector OP is equal to vector R. Okay. Now then the point P will lies on this plane if and only if this AP, this if you join AP is perpendicular to the vector n. See here, now join OA, OP and AP, then this line, that is the point P lies on the plane if and only if the vector AP is perpendicular to n. What is the condition for perpendicularity? A dot B is equal to 0. That means vector AP dot n is equal to 0. Therefore, vector AP dot n is equal to 0. This is the condition. Very simple. See, this is the very important, and you have to, a plane passes through a point A whose position vector is vector OA is equal to vector A, that is vector perpendicular to the vector n. Let P x, y, z be any point on the plane whose position vector is vector OP is equal to vector R. Then the point P lies on the plane, if and only if the line AP, if the vector AP is perpendicular to n, if and only if the vector AP is perpendicular to n. Perpendicular to means AP dot n is equal to 0, vector AP dot n is equal to 0. Now from this we are going to derive. Now what is AP? From this diagram, vector AP can also be written as, from figure, vector AP can be written as OP minus OA vector. OP minus OA vector. Now what is OP? OP is equal to vector R minus, what is OA vector? Vector A. So vector AP is equal to R minus A. So therefore, since vector AP dot n is equal to 0, AP is nothing but vector OP minus OA dot n is equal to 0, that is vector R minus A dot n is equal to 0. So therefore the equation R minus A vector dot n is equal to 0 is the vector equation of the plane. This is the first part. If you do this 2 plus 1 marks per diagram, 3 marks you will get. So R minus A dot n is equal to 0 is the vector equation of the plane. That's it. Since what is the point given? Now let us find the Cartesian form. Second, Cartesian form. Now what is the Cartesian form? Since the plane passes through the point A and P is any point. So, therefore, write down here, since the plane passes through the point A, x1, y1 and z1. Since the passes through the point x1, y1 and z1, whose position vector is vector OA is nothing but vector A is equal to x1i plus y1j plus z1k. Okay. Now, this is vector A. Now, suppose if capital A, B, C, if A, B, C are direction cosines DCS, direction cosines of the line N, vector N, if A, comma B, comma C are the direction cosines of vector N, then this vector N can be written as vector N is equal to A into vector I plus capital B into vector J plus C into vector z cap. So, vector n is equal to a into I cap plus b into j cap plus c into z cap. See here, let a x1, y1, z1 be any point on the plane. Therefore, the position vector is OA is equal to x1i plus y1j plus z1k. Let a, b, c are the direction cosines of the vector n. Therefore, vector n is equal to a into I, b into j plus c into k. It is, sorry, not z, it is k. That is ai plus bj plus c into vector k. Let p x y z be any point on the plane. Therefore, the position vector of OP is OP. OP is equal to vector OP is equal to vector r. This can be written as xi plus yj plus zk. Now, substitute these values in this equation. So, you know vector r, vector a and vector n. Take the dot product, you will get the answer. That's it. Now, from vector equation, from vector form, what is vector form? Vector r minus a dot n is equal to 0. Now, what is r? Vector r is equal to xi plus yj plus zk, xi plus yj plus zk minus, what is vector a? Vector a is equal to x1i plus y1j plus z1k. If you multiply by negative sign, x1i minus y1j minus z1k dot, what is dot n? N is equal to vector ai plus bj plus ck, vector a into I plus b into j plus c into k is equal to 0. Now, simplify this. This can be written as x minus x1 into I plus y minus y1 into j plus z minus z1 into k dot, this is vector a into I plus b into j plus c into k cap is equal to 0. Now, take the dot product of this x minus x1 into a, x minus x1 into a plus y minus y1 into b plus z minus z1 into c is equal to 0. So, therefore, the equation of the plane is, therefore, a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0 is the equation of the plane. That is all. Therefore, the equation of the plane is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is the required equation of the plane. So, if you do this much, you will get 5 marks. Very simple. Definitely you will get this type of questions. Okay. Now, let us come to the last concept. So, the last two problems are from probability. Right. Now, let us come to the last two problems. Question number 62. That is from probability. Now, what is the problem? A person buys a lottery ticket. A person buys a lottery ticket in 50 ticket. In 50 lotteries, in each of which is chance of winning a prize is 1 by 100. What is the probability that he will win a prize at least once? Exactly once. See, a person buys a lottery ticket in 50 lotteries, in each of which his chance of winning a prize is 1 by 100. If such is the case, what is the probability that he will win a prize at least once or exactly once? Okay, two cases are given here. Now, this is very simple problem. Now, the given problem is a Bernoulli's trial. So, this can be solved using the concept of Bernoulli's trial. So, this is the Bernoulli's trial with n is equal to 50. What is n? N is equal to 50. Okay, let us solve this. So, given trial is a Bernoulli's trial. Now, with n is equal to 50, right? What is given? Given winning prize as a success. So, therefore, winning the prize is given as P is equal to 1/100. This is called the success. Now, not winning a prize, that is called a 1 minus 1 by P. That is equal to 1 minus 1 by 100. That is 100 minus 1 is 99 by 100. What is this? That is called not winning the prize. And this is denoted as Q. So, therefore, P is equal to 1 by 100, Q is equal to 99 by 100. Now, we know when the probability using Bernoulli's concept, P of probability of x is equal to x is given by NCX q to the power of n minus x into NCX q to the power of n minus x into P to the power of x. This is the Bernoulli's formula. That is P x is equal to x is given by NCX q to the power of n minus x P to the power of x. Now, substitute the values. So, this is equal to what is n? 50Cx. Q, what is Q? Q is 99 by 100 to the power of 50 minus x into P. What is P? 1 by 100 to the power of x. Okay, this is the problem. So, 50Cx into 99 by 100, 50 to the power of 50 minus x into 1 by 100 to the power of x. Now, let us come to the case 1. What is the case 1? At least once. At least once means probability of x is greater than or equal to 1. At least 1. Probability of x is greater than or equal to 1. So, that is equal to, substitute here. So, that is nothing but that is equal to 1 minus probability of x is equal to 0. This is equal to 1 minus probability of x is equal to 0. Put x is equal to 0 here, that is it. So, if you put x is equal to 0, 50C0 into 99 by 100 to the power of 50 minus 0 into 1 by 100 to the power of 0. Now, what is this equal to? 1 minus 50C0 99 by 100 to the power of 50 into 1 by 100 to the power of 0 is equal to 1. Now, this can be written as 1 minus 50C0 is 1 into 99 by 100 to the power of 50. So, therefore, probability of x is greater than or equal to 1. That means, at least once getting a lottery, at least once is equal to 1 minus 99 by 100 to the power of 50. This is the first chance. Okay, that's it. Now, let us come to the second part. What is the second part? Exactly 1 means x is equal to 1. That's all. Now, second one, exactly 1 means probability of x is equal to 1. So, this is equal to, substitute here, 50C1 into 99 by 100 to the power of 50 minus 1 into 1 by 100 to the power of x is 1. Simplify this, that is it. So, this is equal to 50C1 is 50. 50 into 99 by 100 to the power of 49 into 1 by 100 to the power of 1 is 1 by 100. Now, this can, you can cancel this, 50 ones are 52 is 100, this is 1 by 2 into, this is 1 by 2 into 99 divided by 100 to the power of 49. This is the required answer. So, what is the probability of winning at least once is 1 by 2 times 1 over 2 times 99 divided by 100 to the power of 49. So, exactly once is 1 minus 99 by 100 to the power of 50. At least exactly once is 1 by 2 into 99 by 100 to the power of 49. This is the required answer. That's it. Very simple and easiest problem. Okay. Let us come to the last problem in this session. Again it is also from probability. What is the problem given? Probability of solving a specific problem independently by A and B are 1 by 2 and 1 by 3. Probability of solving independently by A is 1 by 2 and B is 1 by 3. Respectively, if both try to solve the problems independently, find the probability that the problem is solved, exactly one of them solves the problem. This is the problem given. Now, let us define that. Let A is an event. Let A be an event that the problem solved by A. Let us define the event A as the problem solved by A. So, problem solved by A. So, therefore, probability of A is given. What is the probability of A? 1 by 2. Similarly, let B be an event that the problem solved by B. That is given by probability of B is equal to 1 by 3. These are the conditions given. Let us define an event A that the problem is solved by A. Therefore, probability of A is 1 by 2 and B is an event that the probability solved by B is 1 by 3. So, P of A is 1 by 2 and P of B is 1 by 3. This is given condition. Since A and B are independent events, so therefore, probability of A intersection B. So, A and B are independent events. So, therefore, probability of A intersection B is equal to probability of A into probability of B. So, probability of A intersection B is equal to, what is probability of A? 1 by 2. What is probability of B? 1 by 3. That is equal to 1 by 6. Since A and B are independent events, therefore, the probability of A intersection B is equal to probability of A into probability of B. That is 1 by 2 into 1 by 3 is equal to 1 by 6. Okay. Now, let us come to the first condition. The problem is solved. Now, let us define the first one. The probability of the problem is solved. So, this is denoted by probability of A union B. So, let the problem is solved. That is probability of A union B is equal to, now what is the formula? We know that probability of A union B is probability of A plus probability of B minus probability of A intersection B. So, that is equal to probability of A is 1 by 2 plus probability is 1 by 3, A intersection B is equal to 1 by 6. Let us take LCM, 6 is the LCM. So, 3 gets cancelled, 3 plus 3 and 2 gets cancelled, minus 1. So, this is equal to 5 minus 1 by 6, 4 by 6, that is nothing but 2 by 3. The probability of problem to be solved is 2 by 3, that is it. What is the second condition? The second condition is exactly one of them solves the problem. Okay. Now, the second one, probability, exactly one of them solves the problem. One of them solves the problem. So, this is nothing but any one. That is nothing but if A solves the problem, B will not solve the problem. If B solves the problem, A will not solve the problem. That is written as, that is probability of A not B plus probability of B not A. That is it. So, this is denoted as probability of A not B means intersection B dash plus probability of B intersection not A means A dash. Probability of A intersection B dash plus probability of B intersection A dash. Now, this is given, there is a formula for this. This can also be written as probability of A minus probability of A intersection B, probability of A intersection B plus probability of B minus again probability of A intersection B. See here, the probability of A not B is A intersection B dash. Probability B not A is nothing but B intersection A dash. So, this is probability of A minus probability of A intersection B plus probability of B minus probability of A intersection B. Substitute, you will get the answer. That is it. So, this can be written as probability of A plus probability of A plus probability of B minus probability of A intersection B minus probability of A intersection is 2 times probability of A intersection B. So, this can be written as, so therefore, this is equal to, what is probability of A? 1 by 2. What is probability of B? 1 by 3 minus 2 times. What is probability of A intersection B? The probability of A intersection B is 1 by 6. 1 by 6. So what is this equal to? 1 by 2 plus 1 by 3 minus 2 ones are 2 3s are 1 by 3. These two gets cancelled. 1 over 2. So therefore the probability of exactly 1 solves the problem is given by 1 by, that's all, 1 by 2. Okay, 50%. That's it. So this is how we are going to solve the problems on a probability. Okay. Now just please solve all these problems. Definitely you will get maximum questions from this for the point of examination. Okay. So these are all the problems based on a 5 marks. So from all the chapters they have taken except from inverse trigonometric functions and from vectors, and all chapters they have taken. So first 6 questions are from relations and functions, then matrices and determinants and differentiation. Remaining 6 questions are from integrations, application of integrations, differential equations, 3D geometry and probability. Okay. So this is very important. So that's regarding the problems for 5 mark questions in this session. Now that's regarding the part D. Now let me discuss with part E in the next session. Don't go attend the class. That's all for today's session. Let us meet with part E problem, 6 marks and 4 marker question in the next session. Thank you.